Good Monday morning! Yeah.
Yay!
Uh,
Hello!
it's actually morning for you. For me, it's not actually morning when I'm recording this, but for you, it's actually what?
Yeah, Saturday morning. But to be fair, it is more like Saturday lunchtime now.
So we're doing a special episode today. We are doing a pair programming episode of a Unity game.
Yes, Clone Drone in the Danger Zone is the new game that I just made.
Yeah, I guess that we should start by telling the audience a bit about you.
Sure, let's do that. So hello, audience. My name is Erik Rydeman. I am an independent game developer, and I just launched the game Clone Drone in the Danger Zone on itch.io. And I've been working on the game since maybe April. I'm still kind of working on it and adding more features, so that's what we're going to do today to make it more awesome. And I've known Matthias for a very long time, since we were little kids. Doing theater and acting.
Yeah, we started our first company together.
Yes.
That's kind of how we knew each other, when we were 17, 18 or something, and we started this web consulting agency.
Yeah, it was pretty cool. Or I guess it wasn't that cool, but we learned a lot from it.
Yeah, that's true. Yeah, fair enough. Yeah, cool was a very strong word for what we were.
Yeah.
But it was great fun.
Absolutely. It's actually a cool story. We've done this before, remote pair programming. I think Matthias is the only person I've ever done that with. It doesn't come up very often. But yeah, we did that for like our second company together, Fat Statement.
Yeah, that's right.
Where we built this website together in much the same way we're gonna work now. So I'm really looking forward to it. I know it's a lot of fun to do it when it works.
So we spent like the last 2 hours doing an enormous amount of setup shite. I had some Wi-Fi trouble. We mixed up time zones, and there was some trouble getting the project running and all that kind of stuff. So programming plus video production is a really good way of having everything break in every conceivable way possible.
Yeah, but on the positive side, it took us a lot less time to do that than if one of us were to fly across the Atlantic and sit next to each other. So I think overall it's a net gain.
All right. So what is the plan here? Perhaps I should just demonstrate the game first.
Yep, sounds good.
So this is Unity. I have worked a little bit in Unity. It's a pretty daunting interface, but it's generally easy to work with. And I'm just gonna hit play here, over here, and that should start the game. Okay, it's whoop, yes, and I click play, and the robot is constructed.
I guess you could turn the sound up to like 10% or something, so people get a hint of what's happening, maybe.
Oh, that's gonna be tricky because I'm not recording the sound from the.
Oh, all right.
We're not,
right.
That's way too complicated for me.
Okay, never mind. The sound is really good. You can take my word for it.
This is an awesome game. This is hilarious. And the thing with this game is that so if you notice that I've cut off this guy's leg, so you like do this partial destruction of the robots, so they don't have any hit points, right?
Mm-hmm. Yeah, that's right.
So
how do they die? Yeah.
So how do they die?
So basically, it's a really cool thing, actually. I'm using Voxels to dynamically kind of change the model as you cut it. So as you can see now, yeah, you can cut it like anywhere, which means that it really respects where your sword hits. So you can cut off like part of a shoulder, doing absolutely no damage to the robot at all in like a meaningful gameplay way, or you can land a shot that like cuts it in half through the spine or the neck, or diagonally, like and it kind of just figures out how to sever the robot. Um, so basically, the rules for if you win or not is if you hit the head, the robot dies. If you sever the head or a body part connected to the head, like the torso, you also die. You can also cut off like both arms, you die because now the robot can't attack you. And yeah, that's pretty much it in terms of how that works.
Can you talk a little bit about what voxels are? Because I don't think that most people know that, and
Right.
I don't.
So, sure. So, I mean, a voxel is essentially, most people know what pixels are, right? Like they are the little things on the screen that together form an image, like where the color shifts from one to the next. So voxels are kind of like that, but in 3D. Basically, if you imagine a lot of little cubes sitting next to each other, with inside like a coordinate system. So that's kind of, then you have a pretty good idea what voxels are. So for this robot, for example, um, there's a lot of information stored about like the model representation isn't like how you would normally store a 3D object, saying, oh, these are like the corners like that together form the shape. It's more saying things like, on this coordinate, there is something there, and it is yellow. In the case of this robot you see fighting right now, for example. Like actually, Matthias, if you pause the game, you can like
Oh, yeah.
highlight a thing and maybe dig into it a little bit. Like if you go and select the player,
Hang on, I'm gonna
there
there. All right.
you go, there you go.
Okay.
Or this guy.
Okay.
Oh,
So
so
how do I say? Oh, I did this bug.
Oh, yeah.
We found a bug where you have to fix it by maximizing and then unmaximizing it again.
It's terrible. Unity. Yeah, so if you go to world,
Yes.
and then if you collapse arena final, because it's taking up all the space, and or actually it might be interesting, go to level specific world root, which is like above world.
Where is it? Oh, okay. Collapse
above
world. Yeah.
Yeah, there you go. So here are like all the objects that are currently associated just with this level that we have right now. So if you click on one of the severed body parts, like yeah, and then double click it, and that will go to it in the scene view. Let's see, double click it.
In the scene view, I need to go. All right.
Let's see. Oh yeah. Okay. So yeah, here you can see. Here's a body part. So I guess there's no easy way to visualize it, but yeah, if you dig into this guy a little bit, like how it's built up, you can see that there is a volume. So this volume has two voxels in it. It has a white voxel and a blue voxel, and that's how it's stored in memory right now. That's what the game knows about this this arm piece. And then there is I'm using a program called Peacock Voxel to take this information and render it into a mesh, to make it into a mesh that is rendered in 3D from the kind of more basic representation of just like, oh, this is what makes up the model. And then on top of that, there's a thing that connects this kind of mesh with the lower arm and the hand and all the other things. And that's more of a custom Unity thing that I've written to store information about how the models are connected to one another in a way that makes it so if you sever one of them, it knows like, okay, who are my children, essentially. Like if I'm the upper arm and I get cut off, I know that I also need to cut off the lower arm as part of me. So, and that's how you kind of get this super dynamic, it looks like there's like a really cool physics system with connections, but it's actually pretty simple in terms of how it fits together.
Sweet.
Not sure if that made any sense, but there's a taste for you.
Yeah, I think it gives the game a really satisfying touch, because you can actually chop the robots off into little. It's kind of like destroying Lego figures, and it just makes it super satisfying to kill things. I really like it.
It also makes it really fun. You can play with you can play with damaging people in ways that actually deforms them. Like later on, there's a spider, for example, that has really long legs, and it doesn't die if you just cut the legs. You have to cut the head of the spider, but you have to start with cutting the legs in order to be able to work your way to the head. So it opens up all kinds of interesting gameplay that I don't think has been seen before a lot. So that's been really interesting to play with.
So what is it that we're gonna do today? Because you have arranged a task for us, for me to do, because I am doing the coding on your game. So this is the first time that somebody else touches your code base, right?
Yes. I picked a task that I think will be small enough that we can actually see completed in a meaningful amount of time, a small amount of time, and see it change in the game. So one of the things that people request a lot is to be able to sprint, to move faster. Oh shit! You lost, Matthias.
Yes. Yes.
Yep. Oh well. That happens. So yes, we're going to implement sprinting.
Sweet.
It's going to work a little bit like you hold down Shift in order to move faster. And while you do that, there's like the concept of energy in the game. You can see it on the screen right now. At the bottom of the game screen, there's like not enough energy, and there's like a bar down there. And the sprinting will consume that energy. Now, as to the design of sprinting, like how will it actually work in the game, you might have noticed the player has this thing on their back, which is shaped a little bit like a jetpack. I kind of put that in early on in the game, but didn't get a chance to do anything with it. So how I envision it will work is you activate sprinting, and the jetpack engages and pushes the player forward in like a straight line. So there are a few different ways that this could work. Like you could fly up into the air while doing it, or you could stick to the ground. You can hold down Shift and it will sprint for the duration and like stop sprinting immediately when you release it, or you can trigger it and it will do it for a set amount of time. I'm not exactly sure which of these versions makes the most sense. So one thing you have to do in game development all the time is to just try it. And that's kind of what we're going to do today. Because all of these kind of variants are, they're kind of small. But it's important to experiment and try it to figure out which one of these things feels the best and is the least confusing and the easiest to control for the player. So that's a thing that we have to play with.
Cool. So which variant is the first one that we're gonna try?
Why don't we just try? You hold down Shift, and that increases that propels you forward. And when you release Shift, that stops propelling you forward. That seems very simple and will force us to build the basics of this ability as well, and get some stuff into place for it.
Sweet.
All right.
So where do we begin?
Let's see. So I think we're gonna probably have to. Let's see what makes sense here. We're going to have to delve into a class called first person controller, or shit, is that what it's called? If you start typing first person, you will find it. First person mover. First person controller is one of these standard Unity classes. So this was probably one of the first classes I created in the project. And what it is, it's basically controlling any character in the game that has 2 legs, 2 arms, and possibly a sword or a bow.
Okay.
Which is most of the enemies. So not the spider. The spider is another class and so on. But it's kind of long, the class, and it controls, kind of controls most of the player's movement and status and so on. So yeah, why don't we open it up in MonoDevelop and we can have a look at it.
First person mover. So I just double click first person mover.
That's right.
That should open MonoDevelop. Okay, cool. All right, C Sharp. I have not done C Sharp for, I think, 10 years probably. It was my first programming language, or technically PHP was my first programming language. But PHP is not so much a language as it is sort of a
collection
craft.
a collection of garbage that you kind of massage and copy around, and eventually, you can make things. Yeah, the computer do something with it, but
yeah, it's sort of like a
I guess
very
it is a
very
language.
yeah. No, PHP is it's a very very useful language. You can say that.
Yeah, it's shouldn't diss it too much. It is very easy to just like slap something together in, but I don't know. You can. Let's not get into that whole thing. That's,
No. We're building a game here, and we're using C Sharp.
Yep. Okay. Cool. So as you can see, I think this is like 1,400 lines long or something, this class. So maybe we don't have to go through all of it in terms before we start touching it. Yeah, it's a little under abstracted, I would say, right now. But the flip side of that is that hopefully most individual parts of it will be pretty straightforward in terms of understanding them and what they do.
Yeah.
Let's see, it might be, maybe it would be, as an example to kind of get you up to speed with how it's structured, if you search for jump in it, that's a kind of a similar thing. That's less complicated than what we envision for sprinting, but this is kind of how jumping works in the game. Yeah, you can see is jumping. Lets people know if we're jumping or not, stored in a private variable. And right now, I believe you are in the update loop, where basically this is executed every frame, and it checks for conditions and does stuff. So here
and
we
this
can
is
see
a very common pattern in game programming, right? Everything runs in this this update loop all the time.
Right. I mean, yeah, it's like each individual object typically has its own update loop where it it kind of keeps track of state and modifies it. Like if you look at projectile, for example, that's a much simpler example of how a typical class might be structured. That's smaller. It's not in this class. It's like a different class somewhere. If you do Command-Shift-D, I believe opens a new, if you just want to search for it in MonoDevelop.
Command-Shift-D. Oh, no.
Am I right? No?
Yes.
Yes, yeah. If you start typing projectile, I believe you will find that guy. Yeah, check out that guy. This is like a much simpler class, for example. I guess it was actually a lot bigger than I imagined, but
wow, it's 200 lines.
Okay, never mind. But it had, oh yeah, here's an update. Yes. It's like does stuff like, oh yeah, increase the position each update. It's like just things like, oh hey, keeps track of where the player is, and if we're near the player, we like whoosh, make a whooshing sound for dramatic effect, and so on. Yeah, sorry, it's a bad example, and also it should probably be using fixed update instead of update, but we're gonna just ignore that completely for now. That's not important. Okay, right. Great.
Sweet.
Okay,
first
so let's go back
mover.
Right. Okay, so let's start looking at jump again. just to kind of give you a sense. So, yep, there's stuff about what is this? Oh yeah, I guess it has all. You can just ignore this. This is some special casey kind of stuff. Yeah, so when you land on the floor, it checks like, oh, hey, I was jumping, stop jumping now. And you can see that the character model here, this is kind of setting the some properties on the animator. So this is kind of a thing in terms of like animating the character. Typically, you could either say, play this animation by name, or you can say, just inform the animator that we are now in this state, and it has its own giant state machine that can transition between states based on logic kind of defined inside of it. So that's something we're going to want to do when we do sprinting as well. But yeah, that's a later concern.
Sweet.
So yeah, let's see. Yeah, can continue searching around a little bit.
Jumping. Oh, this is when it jumps on the other leg. That's another
Right.
thing.
Yeah, maybe jumping was, it's funny, like in my mind, I'm like, oh yeah, look at this class, look at this thing. It's so simple, but then it's like 20 different areas and everything. It's not that simple. This is called having written the code yourself. Then everything is very simple and straightforward.
Yeah, but the scope of, just to give people an idea, like this game was written in a very short amount of time, right?
Yes, since April this year. So like 6 months, more or less, or maybe 5 months. I did marketing for like the last month before launching it. So yeah, it's still very. A lot of things are maybe it's the first pass on them, so to speak, and I think that's a really good thing to do. I don't think I would be finished if I started abstracting everything prematurely. That's a thing I try to avoid typically. Like for example, there is no weapon class in the game because you have two weapons. Like that's one of those standard things that you might see in your typical shooter, your typical kind of game architecture. But because I only have two weapons, it hasn't come up yet, and those two weapons are so different. Cutting someone with a sword versus shooting someone with a bow, very different. So they're all kind of large parts of them are baked into this class. But yeah, as a good rule of thumb, I think it's good to start in like in a very concrete way, in a very like, I'm gonna add it and it's gonna do something very straightforward in a very straightforward way, and we're gonna call it what it is, not sort of some abstract name that we think might be reusable later. And if you couple that with a tendency to refactor ruthlessly, when you run into something that could be better, or like, oh, now I need this abstraction, I'm going to break it out from where it is right now, that's when you get really fast and really powerful and end up with code that serves its purpose and starts being really, it is pretty easy to get into and change.
I find that especially when it comes to object-oriented code, it's very easy to fall into the abstraction hellhole, where you start, we see like two things that are kind of sort of the same, and you start to you feel like, oh, this is sort of duplication, and you start generalizing it. But once you start generalizing it, you realize that it's not as general as it seemed up front, and you end up with this much more convoluted solution that is actually a lot more code and a lot of more moving parts than the individual solution and the individual duplication was.
And also, it's harder to understand probably because now you're not calling a sword or a jump a jump. You're calling it an abstract I action implementer or whatever it is.
Yeah.
And no one understands what it is, and you have to read it for 20 minutes before you understand what is happening. So of course you get more bugs because no one can keep all of that in their mind and think of cool like edge cases because they just don't understand what's happening. Cool. So now that I have defended the honor of my code, maybe we can look at actually modifying it. So
Yeah.
why don't we just I know how this code works. Why don't I tell you roughly what I think we could start doing, and we start doing it a little bit, and then you'll kind of get into you'll learn by doing it and also
Yeah.
seeing the surrounding code next to where we will add stuff.
Yeah, sure. I'll just ask questions when I'm confused and you'll explain stuff.
That sounds great. And you'll have to because you're typing it, so you have to know what to do. Okay, so if you go to the top of the file again, there are a bunch of things for tracking here in terms of what key is down.
Also it's these is moving things. These.
Even further up,
Oh.
like to the private parts of it. Let's see. Oh yeah. So there are two things here, or many things, but two main things. There's is moving, is jumping, is kicking, is falling, is on the floor. Like all these kind of things. It's okay, this is stuff that we are doing. There's another part. Oh wait, that's not in this class. That is in the base class.
If you you did generalize it.
I did generalize it. I have a goddamn spider.
Okay.
I have to have some concept of a character or an enemy or something. Command D in the latest you want to develop.
So I'll just go to declaration. I don't. Okay. I try not to use hotkeys so that people see what I'm doing.
That makes a lot of sense. All right, that sounds great. Yeah, so here you can see down key down, up key down, left key down, blah, 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 horizontal cursor movement. And the reason I store that here in this way is because the AI is using the same interface as the player is to control the character. That's a pretty standard pattern in game development that's really important. It makes it so that you don't have a special way for the AI to steer the character. That can be, it's a nice way to, reuse the same things, and that you don't have to make anything super special. And it also makes it so that, hey, if I as the player want to suddenly be a spider, I can totally be a spider and control it with the normal controls.
That's good.
And that sort of thing. So you can swap out you can separate, I am the player and I'm controlling it, from what is it doing? What capabilities does it have? So this is a simple example of that.
Cool.
So let's add another Boolean.
Yes.
Protected bool. Let's call it sprint key down.
Okay. So protected, that means that it's private, but also that subclasses can access it, right?
Exactly. It's not public. You can access it from the outside, but yeah, every subclass can access it.
Cool.
And that's what we want. Okay, so now we need to do a little bit of setter logic. If you scroll down a bit, there's a bunch of very similar looking methods here. Yeah, just add another one to the end here. Public void set sprint key down. It's a Boolean, bool value, and we can already anticipate we're going to want set sprint key up as well. But let's finish this first. Set sprint key down equals value. No. It could also be false, I guess.
Yeah, that's true.
Actually, no. Yeah. We don't need a sprint key up then, because then we're just going to use set sprint key down false instead. That's cool. Okay.
Okay.
Yeah, you can. I misspoke. No.
Okay. Bool.
Yeah. Oh, you don't need a getter for it. No. We don't need a getter for it.
Okay.
That's right. Yeah, so this is C# does have you can do getter and setters more by magic, but I like just wrapping them myself like this.
Yeah, I've never been a fan of the magic getter and setters.
It's almost it's like not having one. It doesn't. I don't know. In this case, we don't really want this is at an abstraction level where I don't anticipate any other class in the system saying, "Hey, you person over there, is your sprint key down?" that's not a thing we're going to ask. We might ask, hey, you, are you sprinting? But that's different from, is your sprint key down? Like if you're on the ground, for example, and you've fallen over, you can't sprint. That's the thing. Like,
yeah, that's a very good point. I think like I was here. I just started doing a getter just out of habit, but that code would just have been dead code if we really didn't use it, and dead code is generally bad to keep in your system because it seems like it's there for some purpose, but it's really just something that somebody has written and it's not tested or anything. It's just a volume of death.
yeah, and I think when it comes to encapsulation like this, I think it's good to start with the assumption that it's private, and then it's fine if you need a getter for it, but now you have to think about it for 2 seconds, and like you have a use case now. And that's just a good way to, I don't know, it's like a rule of thumb. It's not a hard and fast rule, but that's my default assumption. It's private. So now we can, if you go back to first person mover, now we can, now we know if the sprint key is down or not. So
Yes.
now we can actually add, now I think we're going to need is sprinting at some point. So you can add it to the, if you go up again a little bit, private bool is, yeah. So at some point later, we can anticipate that we're going to say something like is sprint key down, and see if we can sprint, and then set is sprinting to true. So yeah, why don't we do that now? Let's go to the update loop, which is down a bit.
Here.
There's all kinds of stuff in here. Yeah. Yeah, so this is basically where we deal with a lot of this stuff. Let's move it down further. We want to do it before, okay, actually, let's see. So it's blah, 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 blah. Here you can see we're figuring out the movement of the player. We're doing stuff like, oh, if we're holding the up key, then say this is the move direction and so on, and we have moved and we want to move, and blah, 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 blah. So somewhere in this general area, I think, might be a good place for tracking it.
Cool.
I'm not sure where exactly. Maybe you could actually do it after the movement.
So could we, yeah, because we have, you're checking if we can't move if we are kicking or on the floor from kick or is falling.
Right, so let's think about the rules of sprinting a little bit.
Does sprinting suffer from this constraint as well? Like, I guess that you wouldn't want to sprint when you're kicking or falling perhaps.
I think, I mean, so keep in mind, this is just triggering it. This is not actually doing the sprinting that we want to do first. I feel like we can just add it somewhere naively and then move it if it turns out that that's not good.
Okay, cool.
So let's just add it. What is this? If, okay, this is about going up. Yeah, here is good. Whatever. This is good. So we want to say something like if the very basic thing, like sprint key is down and we're not sprinting.
And we are not sprinting.
It's sprinting, yep. Then we want to start sprinting.
So how do we accomplish that?
Let's say is sprinting is true.
Oh.
And it doesn't do anything yet, of course, but okay, great. Now we are sprinting.
Okay.
Cool. So as I mentioned before, the very basic version of this is purely that we increase the speed in the forward direction.
Sure.
So let's look at the move direction stuff above for a second. Like where it sets the move direction. So we're saying, okay, up, down, left, right, change the move direction. Why don't we, if you find usages of move direction, that's going to get us to the code that we want to look at next.
Okay, find references of move direction.
Yep.
All right. So here's it.
Cool. Yeah, that's those guys. And you see we normalize it to make sure that we don't get a. Oh yeah. So down here, desired move vector. If you double click on that guy, that's where we're going. Okay. Cool, so let's look at this code. Desired move vector is the move direction times the distance moved this frame.
Can we give people just a super fast crash course on what a vector is?
Yes, an excellent question. So a vector is basically, it represents an x, y, and z. So a vector 3 has x, y, and z. A vector 2 has only x and y. So it's basically a position or a direction, typically. It's something to do with 3D space. And it what it is, it kind of depends on what you call the variable and so on. But the values on it is x, y, z.
So in this case, on line 354, for instance, desired move vector.
Right, so this is the how far to move this frame. And you can see it's using the move direction, which is basically saying if we're holding the forward key and the right key, for example, move direction will be something like it will have an x and a z value pointing in the direction of forward and right, and the sum of it will be 1. It's also important to note. If you take the distance of the x, y, z, you get 1 because we've normalized it. So that's like the direction that we're pointing at. And then distance to move this frame is you can find where this is declared as well, and have a look at that because it might need some context. Yep, if you jump up a bit. So the distance to move is the elapsed time delta time between this frame and the last frame times the movement speed that we have times the movement speed multiplier, which is like if we're suffering from some kind of boost or some kind of slowdown or whatever it might be.
Yeah. So this might be actually code that we will be touching later.
Totally. Absolutely. The naive version would just be to say, hey, move speed multiplier, you are ×2 or something.
Yeah.
That would be a very naive version, but that might be pretty okay. But we kind of want to do something more complicated than that, unfortunately. Like, it's worth noting, I haven't really prepared or done any research on exactly what this code will look like. I'm trying to figure it out as we go along as well.
I think that that is the way we should do it, because we want to represent kind of like how this would work in real life, actually figuring out how we're going to do it. We don't want it to be like clean and prepared, and we want
yeah, then no one will learn anything. Exactly. I'm also confronted by the various awkward parts of this code that I've written. It's just that having to explain it is like...
I don't think that long classes are like... I don't mind this at all, actually. I'm a person that there is one thing that is a lot worse than long classes, and that is classes where you have to jump around like crazy just to follow a flow, where it's like there's just this function that does something and then you have to jump into that function. And what's even worse, if it's that function has like access to the state that you're dealing with, so you have to keep in mind that what that thing was over there while you're dealing with over there, where people have like extracted things out like not cleanly. That's a lot worse than a long class.
Okay, so I think what we could do here is to get to the kind of thing that we wanna experience. We could we can add a thing to the desired move vector here. Like basically what we want to do is we want to change the target position a little bit.
Yeah, this one.
Right, exactly. We wanna like give it a boost in the forward direction. So maybe we can even just say here target position, like basically say if is sprinting target position plus equals something or other. If we are sprinting, we have like this jetpack engaged and we're boosting us in the forward direction. So what we could say here is target position plus equals transform dot forward. Transform with a small t. This references the transform component on this object, which kind of keeps track.
That's a Unity thing.
It's a Unity thing, yeah. It keeps track of the position in the world and its rotation and scale. So if we say transform.forward, that gives us the direction of how we're facing right now.
Oh.
So what we want to do in addition to this, though, is to multiply it by time.delta time. And this kind of makes sure, because we're doing this every frame, we only want to like do parts of it. And the final step would be to add some sort of speed increase as well, like a float number that could be anything at all. But yeah, 1.2, why not? Why not? Sounds good.
And delta time, this is the time that has passed since the last frame, right?
Exactly.
Yeah.
So this will be interesting because it will kind of boost us in a just straightforward. So if we're like running to the right and we sprint, we're actually going forward, not to the right. So it's a little bit of a non-standard sprinting mechanic, but I'm thinking of it more as a charge mechanic where you're charging forward with your sword. And later on, we also want to do things like you have special swings when this is engaged, and you're just like gliding through and slicing people.
Nice.
So that's where we're going with it. I mean, let's just try this.
All right. So don't we have to like connect the sprint button to the actual button?
You're right, we do. So if you go to, let's see, what is it? It's something like player input something or other. Control Shift D. Control Shift D. I think it's player input controller.
Okay, Control Shift D. No, Command Shift D.
Command Shift D. Yeah, sorry.
Yeah. And controller something.
Yeah, player input controller. There you go.
Player input controller. There we go.
Right. So this is on the player object, but not on the enemy object. And here you can see what it's up to. So we can just say...
here's some stuff.
Yeah, exactly. It's pretty straightforward. So here we can just say character dot set sprint button down, I believe, sprint key down. Yep. And input dot shifts or something like that. Input. I think it's just called left shift probably. No? Hello? S?
No.
Oh, I'm sorry. Oh no, I'm following. It's input.getKey. Get key and then key code dot left shift or shift. Left shift. There you go.
Cool.
Okay, sweet. So this means every frame it's gonna say is the sprint key down. It is down if left shift is down.
Okay, so input get key, this is gonna return a Boolean.
Yes, exactly.
Okay, so it's like, back to, because this is so unintuitive for an app programmer, like everything runs all the time. So whenever I'm holding this down, I'm holding down the left shift, it's gonna run this like 60 times per second. And when it hits this code, it's gonna see that, he's holding down left shift now, and then this is going to be true, and then it's going to be passed to set sprint key down.
Right, exactly. Like you can see some other variants of this above, like for jumping, for example. This maybe should have been called something a little bit different, but that only triggers when you actually press the jump button, not when it's held down. Because this is movement related, right now in our initial version, we're envisioning it as, okay, you hold it down, and that's the duration of you sprinting. Cool. Let's try it. I'm curious to see what happens.
All right. I'm gonna find a way to switch back to Unity. Oh, I need to save this, I guess.
Oh, yes.
Save all this stuff. Yeah. And then we go back to Unity, and let's see it crash.
No.
Hey. Nah.
First try. It's gonna be great.
All right. Play. Come on, play. What is happening? Oh, compiler error has to be fixed.
I guess you're
okay.
right.
Wait. We have a parsing error.
What? Did you maybe leave out a closing space or something? Oh, go back to Unity and double click the error, and it will take you to where it is. Down key down is false. Yeah, I think you must have messed up a space or a bracket or something when you added it up. No,
okay.
don't touch that.
Hang on, I'll check tower. Hang on. Oh my god. Hang on. I did this. No, that looks fine. That looks fine. Oh, I added this.
Yeah.
577 in first. I'll just discard that chunk. Hang on. No, I'm just gonna make sure it's nothing else is part of that chunk. Okay, discard changes. There we go.
Sweet.
See if that changes things. Let's go back to Unity. How can I will it automatically? All right, int does not contain. Oh wait, it's me that.
Oh, yeah. You have to add f after it, so to indicate that it's a float value.
Yep. Cool.
Sweet.
Going back to Unity. All right, see if it disappears magically. It did. Let's play. So we're playing this. The reason we're using so low resolution is that my computer is doing an insane amount of things. It's broadcasting it's encoding stream to you of the game while I'm doing Unity, while I'm recording the screen for the casts. It's like crazy. Okay, I'm gonna try sprinting now.
Yep.
Maybe I'm faster. I think I'm faster.
If you stop holding down your arrow keys, I would expect it to move you forward because we never turn it off.
Oh, no, it doesn't. If I hold down shift.
That's strange. It doesn't seem to work. Why not,
well,
I wonder?
I get the feeling that it... Hang on. Let me just change the number to something crazy.
Yeah, so if we are sprinting, then we are increasing it by a significant amount. Oh, wait! Yeah. No, actually, I think your movement speed normally is around 12. So, yeah, it would be in that general order of magnitude for it to have an effect. You're right. What did you change it to?
4 times 4.
Oh, okay. Yeah, it's not that crazy, but it's a little crazy. Yeah, you look faster, I think.
Yeah, I'm definitely faster. For debugging purposes, I'm gonna do it even faster. Or also because I just can. Like 40.
Yes, let's do it. Let's see. This is in general with tuning as well. You should never just be like, oh, I'm gonna add it. Like if you have 4 and you want it to be more than 4, you shouldn't add 5. You should add 12 or something. You know.
Yeah.
20, just to exaggerate and see if that was too much, and then like hone in on it like that, so you really feel the difference instead of just convincing yourself that you felt something.
Yes,
there
it
you
works
go.
Now. Yeah, so
this is awesome.
Hang on.
Oh, and then we
have the bug. Yeah. Unity is Unity. And return to game. Where am I?
Are you? Wait.
Okay, wait. I cannot. Okay, it's broke. Okay. I'm not really sure what I'm doing now. I can't stop. Oh, how does... I can't walk backwards now.
Oh, yeah, it's
When I press
because
backwards, it moves forward.
yeah,
And
your
when I move
forward
forward,
movement
it's
is greater
really
than your
fast.
backward movement is
Yeah.
the thing. It's strange. If you just stopped moving altogether, I would expect you to still kind of drift forward because we
No, I'm
haven't
not.
turned sprinting. Huh, must be some
No,
if
it's...
statement they're saying about, only change it if we're moving.
All right, cool.
Yeah, but okay. Well, seems to be working.
All right. So what's the next action here?
Let's see. So now we are sprinting. We could, you could maybe data drive this value so we can tune it more easily. The way to do that
Oh,
would be to declare a public variable at the very top of the class. I believe there is like a move speed or something at the very top.
all right. And then they become accessible in the Unity interface, right?
Yep, that's right. So let's see. Oh, it's on character, actually. But no one else is really moving. Let's see. Yeah, maybe add it on character and we'll be the only one to use it. I think that's fine.
Okay.
Okay. Oh yeah, so up there, max speed, public float, sprint speed.
Cool.
Cool.
That shouldn't have any default value or sorts.
No, because it's gonna get out of date really quickly, and it's just gonna be confusing as to why that's a good value. We don't know what a good value is. Future us will know. Yeah,
Okay,
but now we do need to assign it a value. Oh, and we also need to swap out the reference to it in here, so it's using this value.
Sprinting here, yeah.
Yep. So let's say
was...
sprint speed. Cool.
Okay, cool.
Okay, so that's nice. So let's go to Unity again.
And we're gonna find...
Yep, in your project view down to your left, next to the console. We're going to go to enemies. The player is also an enemy in this setting. Oh,
right.
It doesn't really make... you can see it. Yeah, that one. Prefabs enemies, exactly. Go into that folder.
Okay, this one, right.
Yeah. So here I have pretty much all...
player.
Exactly. So he now has a sprint speed up there.
Right. There's sprint speed. Oh, so I can change this dynamically during the game now, right?
Yes, you can. Yeah, let's say 10, maybe 12. I don't know.
All right. Let's see. Pick a voxel. Hello. What happened?
Yep.
It didn't start. Wait, why didn't it start?
Wait, you haven't assigned a speed either, so.
All right. I'm gonna. Okay. Sprint speed. If I do like 20, perhaps that's same.
But hey, you just made his attack speed 0, which is gonna be troublesome.
Oh. Right.
Yep. All right. 1 is the attack speed. So this is a good thing actually about being in play mode. It doesn't keep any of these values.
Yeah, right. So it just it's really hard to accurately switch between. Okay, so that bug again. Hang on. Now I don't feel it at all.
Really?
No. No, I need to. Sprint speed 50. I'm just gonna do some crazy. Okay, walking, and no, I'm holding in shift, but it's not.
Man, this is crazy. Oh, okay. Oh, wait, sorry. I know why. It's because you're editing the prefab right now, and the player on the screen already has a value set when you instantiated it, so it won't just pick it up if you change the prefab.
Okay. All right. So a prefab is like the thing that you make in your library in Unity.
Exactly.
Or
so,
what is it? Yeah.
Yeah, exactly. It's the it's like the representation of what a player is like. So we could have 5 players at once that are copies of this prefab, for example, and they would all work, and they would it would be 5 cameras, so it would be confusing. But that would totally be they would be instances of the player.
So we need to find the actual player.
Oh no, don't worry about it. So now that you've set it on the prefab, and you run the game again, then the player that I just instantiated will have the new speed. So now it should be really fast.
Okay. So we need to actually set it on the prefab while we're not in play mode.
Right, exactly.
Okay.
So we go back to project, mech player,
and let's say the sprint speed 30.
Sure.
Play, and yeah.
That was
this
really
is a
fast.
bit fast. Yeah. This is
okay,
also,
this is good. This is
yeah. Also, the sprint does not stop when I once I release the sprint key.
Yes, that's because we haven't written any code to do that yet.
Cool. Perhaps I think perhaps 15 is okay.
Sure.
Gotta feel 15.
That is so fast.
Yeah, that. I think this is. Let's leave it at 15.
Okay, so it's sprinting. Then we increase the position. That works okay for now. We might want to do something more sophisticated with it later, but this does in fact move the player forward at a good speed. Oh, actually, can you go up a bit to the top of this if statement, whatever it is?
Yeah.
Yeah. Okay, so I was confused when I saw it because I was expecting it to have this constant forward momentum, but I see now why that's not the case. It's because we have this if statement here saying, hey, if we moved this frame, then change the velocity. So let's see if it makes sense to add a sprinting to these kind of else conditions here. To make it so that even if you're not holding down any of the WASD keys, it's still sprinting.
Okay.
And that's a little crazy maybe, but imagine if you are it will make sense when we add some actual particle systems and things to communicate that this thing is a jetpack. So if we're just standing around and we press it, we would expect us to shoot forward instantly. That's like the vision of where we're going with it, even though it doesn't look like that now. So so this would make more sense like this.
Right. Let me try that.
Yep.
So this should now mean that I get movement even when I'm not moving forward. And sprint.
So if you just hold down shift.
Yes. So
excellent.
now I'm pressing shift.
And now if you let go of shift, I would expect it to just continue zipping around. Is that right?
Yes. Yeah. I'm letting go.
Excellent.
I'm not touching shift.
That's great. Yeah, so I mean, obviously this is not what we want, but this is what we expect. We understand the code we have just written. This is great. Okay. So great. So maybe that's a good thing to fix right now.
Let's do it.
The sprint key. Yeah. So if you go back to if you search for is sprinting in this file, we can see where we set it based on if the sprint key is down. Let's unset it when it is not down.
Oh yeah.
So basically here we can say else is sprinting is false for now.
Can I make it in one statement?
Yeah. And actually this is a little strange because, yeah, you could just say...
I can just say this, right?
Yeah, this is a little retarded. You could just say is sprinting is equal to is the sprint key down for now.
Oh,
And just remove the if we're not sprinting for now.
okay. Cool.
Later on, we might want to do more like an activation and then a deactivation that happens independently of you holding down shift or not. But for now, this is like the one-to-one mapping that we have in the system, so it's fine.
Cool.
Cool.
So let's test that.
Yep, sounds good.
Okay, play, right shift. Yes.
Nice. So now we're like, look at that. It actually already feels more like a jetpack than it did before. Oh, here's the fun thing to try, by the way. If you look up at the ceiling and fly, use it. Does it have enough force to lift you off the ground? I don't think it does.
I think it does.
It does? Are you? It's
no,
like,
it's,
but gravity
no,
is still a greater
it's very
force.
hard to see, but yeah. No, I don't think it does.
Okay.
But if I raised, but it would if I had a higher number, I guess.
Yeah, totally. Because we're not like removing the Y component, which we are for the normal move speed. Why don't we add a particle system?
Yes, let's do that.
Let's make it look like a jetpack. Great. So let's go back into Unity in order to accomplish this.
Shoot.
And let's see. Let's go to a new scene so we can do some work here.
All right, cool. I'm gonna create a new scene.
Okay. And if you go into the prefabs folder and go to character models, we want to take the player's character and drag it onto the scene. And basically what we want to do is we want to just get a really simple particle system going to indicate that sprinting, or in this case, the jetpack is engaged. So here you can see, this is like the character model. The stuff from the intro sequence is actually baked into the model. As you can tell, it has giant welding arms on it that is hidden later. So for now, I think we can be okay with the player being the only guy who can sprint, and then later I can add it to other enemies.
All right.
Okay, so let's see, what do we want to do here? Let's add a particle system to the player. So if you open up character model, like in the hierarchy here, sorry, in the hierarchy, yeah.
Oops, sorry.
Yeah. So if you start expanding this a little bit, you can see that this is like the object hierarchy of what makes up the player. What we want to do is we want to add
legs and leg lower and
blah blah blah. So if you drill into the spine down there.
All right, I'm gonna collapse the legs, open up the spine.
And here we have the torso programmatically controlled, and then the torso, and then inside here, head, arms, and whatever. But the jetpack, if you rotate the model around, or the view around of the model, in the scene view, you can tell that it has like a jetpack on his back. So
I need to learn how to rotate. Whoops, I shouldn't have
done that. Don't rotate that.
Okay, I need to rotate the model.
So hold
like that. So that.
You can do that. It doesn't matter that much. Yeah. No, I mean, if you hold down Alt, and I think it's the middle key on a mouse. This is just in my muscle memory. I don't actually know what I'm doing when I do this.
Yeah. Yep.
Okay. Yeah, that's rotating the view. And I think if you scroll up or down, you zoom in or out as well. Yes. There you go. Yeah, so this is his jetpack on the back. Okay, so what we want to do now, I think the simplest thing we could possibly do here is just to add a particle system, parent it to the torso, and then turn it on and off. And we can expand on that later. So what you want to do is you want to go to File, up in your menu you have somewhere, File, Game Object, New. Sorry, no, I'm just kidding. Not File, Game Object. I just, 3D object. Yeah, there you go. Excellent. This is the fun part of working on games. So hey, now we have a particle system.
Done. Okay.
Done. Ship
But
it.
it's yeah, but it's on the root, right? It's not on the character model yet.
Right. So let's just drag it into the torso up there.
Okay, like that.
Yep.
Oh.
No, not on the head.
No, I think it's in the head. It's hard to hit. There.
Great. Yes, and let's rename it as well. Just select the name up in the editor there in the inspector and call it
over here?
Jetpack. Yep, Jetpack Flames. That's what it will be like. Cool. Yeah, you can see you're given a preview of what is happening. If you zoom out a bit from in the scene view, you can see that it's a really big particle system.
Yeah.
So we want to tweak it to be a little bit smaller. So here are like all the tuning values of the particle system. You can see already that these particles are really big. We probably want them to be smaller. So maybe the first thing you can do is change the size, the start size down to be 0.2 or something. Looks kind of good. And also, it's like they're flying off into space everywhere. So maybe reduce the start speed to 1 or something. See what that's like. Now you can see, okay, they're a lot denser. That's cool. They live forever. We don't want that. So let's say the lifetime is 1 as well. So we have more of a smaller kind of burst. Maybe the lifetime is something like that. Sure. What else do we want to do? We can see the emission is happening from a very wide area. We want it to be contained inside of the little jetpack thing. So if you go to, I think it's shape under emission.
Here.
Yeah, you can see it's a cone, and the base of the cone is 1. Let's set the base to be 0.05 or something, like the radius of it.
What do you see the base?
Shape, under shape, radius.
Oh, radius.
So let's set that to something very close to 0, but not quite 0. Like, yeah, like that. That's pretty good. Great, and this really highlights that this particle system is rotated the wrong way. So let's fix that too. If we go up to the transform, at the very top, above all this stuff,
okay.
This so actually controls the rotation. Oh, and I think because you rotated the character model earlier, it has a really weird rotation right now. Maybe let's normalize this again. Go to in the hierarchy, go to character model player and just set his rotation to 0.
0.
Yep, 0, 0, 0, 0, 0.
I'm putting the.
Oh, yeah,
I accidentally changed the position.
0 and. Oh no, no. So this. Yeah, hold down the right mouse button. You got it. Yes, you got it. Nice. Rotate, rotate, rotate.
There. I think this is going to be good.
Yep, okay. Great, so now you can, let's just see what happens if you set all the rotation to 0 here too. What does that give us?
0 and 0.
That's a good starting point. Okay, great. Yeah, so we can see we want it to be rotated 180 degrees, so maybe just slap that on the X. And that will reverse its facing direction. There you go. Yeah. This is pretty good. Okay, so now we want to change the
position, right?
Yep. So now we want to tweak that to be inside. Beautiful, I think.
Yes.
It's close enough. Close enough. We don't have that much time.
Close enough.
Okay, so let's go to emission as well. We want this to be. I'm gonna pimp this a bit. And 40, why not? Yeah. No, that's too much. 15, I'm sorry. Something. I don't know. We're just like tweaking the general cone of it.
Yeah.
Cool, but now we can see that, hey, the jetpack is engaged. And of course we can change the color and that. Actually, let's do that. Let's change the color to be some sort of fiery red or something. It's up there. That's that color over lifetime and that sort of thing. Let's just say.
Where's the color?
Start color up there. In the first section.
I see it. I see it. I see it.
Completely white. So let's just pick a cool color. Looks like shit, but that's fine.
Could be.
I'll let you be the
Turquoise.
artist. Yeah, sure.
Yeah, if we just have one color, I think turquoise is nice.
Yep, exactly. Normally, later we probably want to add smoke and all kinds of cool effects and stuff. But this is a good like prototype. This is a great prototype.
Because you can use the particle system for a lot of things, like making fire essentially, and explode.
Exactly, and you can like have multiple. Normally, you have multiple particle systems, like parented to one another and working together to create the illusion of something or other. But this is a good placeholder. So basically, now we need to make the player aware that this thing exists. So we need to go and edit the character model class, which is kind of what's used to keep track of what is in the character model, like the animators and so on. So we need to add a field in this class for our particle system. So what we want to do now is we want to add a reference to the particle system we just created.
All right.
So let's say, yeah.
So I guess I go
public particle system. Particle system. You might need to like, yeah, there you go. Sprinting VFX. Let's call it that. Cool. Sounds great. So now that we have that here, what we want to do is in the first person mover, we want to turn this on and off. Now it is public here, but it would be nicer if the first person mover didn't like reference it directly maybe. So why don't we make a new method in character model that says something like set sprinting effect visible.
Visible.
Yep.
And I guess a bool.
Yep. Value or visible or something. Yep. So, and all this has to do is, like for now, the easiest thing to do is just to say sprinting effect dot game object dot set active value.
And this is all Unity stuff, right?
Yeah, exactly. Set active is a method, so you pass value into it and it sets it to be. Yeah, so yeah, what this does is it basically turns the object on or off in the hierarchy. So a lot of the time you want to have something that is not active, that is just waiting to be turned on and doesn't that it already lives in memory and is ready to go for performance reasons. We want to have this method be have a big S because it is public, and that is the naming convention that we have in this project.
Cool.
Cool. Great. So actually, so we probably also want to add an if statement here saying if sprinting effect is not equal to null, because not all character models has a sprinting effect necessarily. But we still want them to be able to sprint just without showing it, perhaps. Yep. Okay, that's pretty good. And yeah, this is like, this is good. Now the character model is like responsible for keeping track of this effect. So in the first person mover, we can now say, in the place where we set if it's sprinting or not, we can also say, oh, right there, you have it up there. We can say character model dot set sprinting effect active, or whatever we called it. Underscore character model.
All right, it's
we should have a reference to it. Yeah. Set sprinting effect visible is sprinting.
Bam.
Very nice. Now, one thing we have to keep in mind is that
I would like to interject here that I hate this thing that it adds a space between these. That is from the moon.
Yeah, who does that? You can remove it. It's fine.
All right.
Okay. There you go. Okay, so another thing we want to do here is we want to make sure that when we first instantiate a new first-person mover, the sprinting effect is not visible. So let's go up to the start method at the very top of this class, and pretty much like right after we instantiate the character model, we can also say, are we doing it in start? We might not be doing it in start. We might be doing it further up. There we go, in awake.
Awake.
So the difference between start and awake is called like the second you have a new one of these within the same frame. Awake is called. Start is called also like at the very beginning of an object's existence, but it's called on the next frame, which is a subtle difference, but it's very important to know it. The rule of thumb is basically you want to set up stuff in awake that is has anything to do with this object that it needs to represent itself and be able to provide functionality for the rest of the system. And in start, you want to start connecting it to the surrounding objects as a general rule. Like you can reach out and assume that other things exist in start, but not in awake. Or vice versa.
Cool.
Okay. Bit of Unity lore for you. So here we can see we're doing all kinds of initializations. So contradicting myself previously, these things just like don't encapsulate it in character model, but we've done that now. So we can just say character model dot set sprint effect visible false. Yeah, that's great. This is a good example of where pair programming leads to better code because you actually have to explain to someone else and justify what you're doing. But you can see I didn't do it down there.
Yeah.
But it would have been nicer if I did, maybe. Okay.
Yeah, I'm a huge fan of pair programming. I think that it's probably one of the most underutilized tricks in the industry. It's just scary how much better code you get when you pair program.
Totally, yeah. You're accountable to someone other than yourself. It's pretty good. Okay, so let's try this. This should work now. This should just work.
Oh, sweet.
Actually, go to. No, I'm kidding. It shouldn't just work. Go to Unity.
You need to connect it as well, right?
Yes, I forgot about that step. Character model player, if you go to the thing in the hierarchy there and select the root of it, there you go. You now see it has a, where is it?
Hang on.
Oh, it hasn't compiled yet. There you go. Sprinting effect, not
so
assigned.
I need to,
yep.
So I drag the jetpack frames. Oh wait. I dragged it into the wrong thing. Why didn't it?
That is a particle system, so it should work.
Okay, hang on. I'm just confused here. Clicky. So, alright, so there's a sprinting effect there. And I drag the jetpack flames.
Maybe you need to hold. Oh, no. You one down by the looks of it. Like drag it. Oh, there you go.
Yeah, I was just dragging it wrong.
That's how you drag. I think.
This is a pretty cool. This is a pretty cool use of static typing. Actually, I think that it just I need to drag a jetpack that particle system in there. Click, drag and drop. It's pretty cool.
It's pretty cool.
I like Unity how it uses it.
Yes, here we are. Okay, great. So let's click apply to make sure it persists. And save the project. Excellent. Now it should just work. Let's go back to the other scene. Well, this won't work, obviously.
Oh, this one. Yeah, okay. Yeah, this is just our bullshit scene. Let's see how to find that one.
Just go to scenes under assets, and it will be there.
Scene. Oh, there.
Okay. Gameplay. There you go.
Don't save this scene. All right. Let's try this. Play. Play. Okay. All right. I'm gonna press shift now.
Yeah. Oh, you placed it from his arm, Matthias. Woohoo! Woohoo!
But it actually does it. It actually does it. Yeah, but like we could tweak this in QA later. QA will have to file a bug and
They
I'll
will
fix it.
catch it. I mean, I thought that was the final look of this effect, but I guess it's not. I guess I'm gonna have to iterate on it a little bit.
But I think that's like I think that we like the purpose of this was to give a sense of the process of making a change in a game and how it all fits together, and I definitely think what we did.
Yeah. Cool. So maybe this is a good stopping point.
I think so. I think that this was great. It was just as fun as I imagined it to be.
Yeah, gameplay engineering is really fun. Like you really get a lot of feedback on your actions, and you know they dance on the screen for you. It's really cool.
Yeah. Like Unity is besides a couple of weird bugs, I think that Unity is lovely to work with.
Oh, absolutely. Like I used to work with Flash before, and Unity is much better in terms of just its workflows and stuff. I would highly recommend it to anyone who wants to get into game development. It's really easy to pick up and learn.
Cool. So before I do the outro, where do people find your game and what's its name?
Oh yeah, so the game is called Clone Drone in the Danger Zone. And you can go to clonedroneinthedangerzone.com, or you could go to itch.io, and right now at least it's in the top sellers list, so that's the easiest way to find it. Or you can scroll down their front page a bit and it's there too. And of course we will link to it in this video because we are goddamn professionals. So
all
actually,
that's
what I should. I think what I should have said is pointing down right now. You can get it from here. Look here.
That's true.
Matthias will edit this later so that here you can click and go get the game. Please buy the game. It's great. Okay.
Also, we're gonna put a few getting started resources for Unity in the description if you want to try out game development yourself.
Yeah, that sounds great.
Well, with that said, thank you so much for watching. You have watched an episode of FunFunFunction. I make these every Monday morning, not exactly like this one, but I release new ones every Monday morning. So you should subscribe, and yes, you should do that. Until next Monday morning, stay curious.
We're waving goodbye together. Bye.
Bye.
Bye. Okay.